for homework tonight, we're going to start getting into angle proofs. So far we've looked at algebraic proofs and segment proofs, and now we're going to see proofs that involve angles. So we need to understand all of the properties of equality, which are all of these. So you should have these in your notebook already. And then properties of congruence, which are the reflexive, symmetric, and transitive. And remember, reflexive, symmetric, and transitive are seen in both properties of equality and properties of congruence. The only difference is that properties of equality, remember, involve a statement that has an equal sign or it's an equation, and then properties of congruence have a statement that are saying two segments are congruent. Okay, so if you have a step that's saying it's the transitive property of congruence, you have to actually say POC or congruence, not just transitive, because it could be a property of equality. Now, some new stuff that we get into are some new definitions. So make sure that you have the properties of equality and congruence, and then we'll go into definitions. All right, definitions. So some of these definitions should hopefully seem a little straightforward, like they should make sense. So the first one is the definition of congruence. And I'm just going to abbreviate definition. Definition of congruence. Now we saw the definition of congruence when it came to angles. We're also going to see it when it comes to, we saw it when it came to segments. Now we see it when it comes to angles. And what it says is this: if the measure of angle A is equal to the measure of angle B, then angle A is congruent to angle B, and vice versa. So this is a if and only if statement. This is a biconditional statement. So I can say if two angles are congruent, then their measures are equal, or I can go the other way, say if their measures are equal, then they are congruent. So anytime I put a little m, that means I'm saying the measure of. Okay. And anytime you use the measure of, it's going to be an statement of equality. If I don't have the m saying the measure of, it's talking about the figure, so it's a statement of congruence. So that's the definition of congruence. The next one is the definition of angle bisector. Now, an angle bisector is not anything new. We've talked about an angle bisector before, okay? Definition of angle bisector says that an angle bisector divides an angle into two equal parts. And we should know that. We've seen angle bisector before. So if I have angle ABC, and let's say that BD is a bisector, we would say that the measure of angle ABD equals the measure of angle DBC or CBD. Okay, that's an angle bisector. Cuts it into two equal parts. The next definition is the definition of complementary angles. And this should be familiar to us. Definition of complementary angles. Well, when we see complementary, we should think 90 degrees, and that's what it says. So it's an if and only if statement, okay? So angles are complementary if and only if their sum is 90 degrees. So keep in mind this is an if and only if statement, so we could say it both ways. We can say if two angles are complementary, then they add to 90, or we could say if two angles add to 90, then they are complementary. That's the definition of complementary angles. Similarly, we have the definition of supplementary angles. And we should be able to predict what this is going to say. It's just like complementary, except their sum is 180. So angles are supplementary, just going to abbreviate, if and only if their sum is 180 degrees. So the definition allows us to go from if angles are supplementary, then they add to 180, or if angles add to 180, then they're supplementary. All right, next definition. We have a lot of definitions. Now we have the definition of perpendicular. And we've talked about perpendicular lines, so this shouldn't be much of a surprise. Definition of perpendicular says that perpendicular lines, and remember perpendicular is used, we use that symbol, it looks like an upside down T. It says perpendicular lines form a right angle, or form right angles. Notice how I wrote that. I didn't say they form 90-degree angles. I said they form right angles. Definition of perpendicular. So our last definition is the definition of right angle. And this just says that a right angle equals 90 degrees. Okay. So we've had some definitions. Now we're going to have one postulate. And we should recognize the word postulate and think about the segment addition postulate. We have the angle addition postulate. And we've talked about this before, but we'll get a little reminder. Let's say we have an angle, ABD, and there's a ray BC. Now, this is not necessarily an angle bisector. It's just a ray or a line or a segment that is cutting through an angle. So we would say that the measure of angle ABC, so ABC, plus the measure of angle CBD equals the measure of the entire angle ABD. Okay, so the measure of angle ABC, so that small angle, plus the measure of CBD, the other part, equals the entire thing ABD. Measures that whole angle. So just like a segment addition postulate, one part plus the other part equals the whole thing. Moving on to theorems. All right, so we have the vertical angles theorem. And the vertical angles theorem says this: if two angles are vertical, then they are congruent. So it's not saying that their measures are equal, it's just saying that they're congruent. Okay. Our second theorem is the complement theorem. Okay. So the complement theorem has to deal with complementary angles. And it says that if two angles form a right angle, then they are complementary. If they form a right angle, then they are complementary. So it says if they are a right angle, then they're complementary. Okay. Doesn't say that they measure 90 degrees, it says that they are complementary. So you guessed it, our next one is going to be the supplement theorem. The supplement theorem says that if two angles form a linear pair, then they are supplementary. So again, it doesn't mention any numbers. It doesn't say 180. It just says that if two angles make a linear pair, then they are supplementary. So when we see that theorem being used in a proof, we're not going to have any numbers associating measures or degrees. It's just going to say these two are a linear pair, therefore they are supplementary. Our second to last one is called the congruent complements theorem. And it's kind of strange, but here's what it says. It says if angle A is complementary to angle B, so we have angle A complementary to a totally different angle B, okay? And angle C is also complementary to angle B, then angle A is congruent to angle C. Okay. So that's our congruent complements theorems. And I like to think of it as if two angles are complementary to the same angle, then those two angles are congruent. Okay. Because think about it. If, let's say, for example, we have angle A, angle B, and angle C. If we say A is complementary to B, let's say we know that A is 40 degrees. The measure of angle A is 40 degrees. Well, if it's complementary to B, then B must equal 50 degrees. And then C is complementary to B. So if C is complementary to B, well, if it's complementary to B, it has to be 40 degrees. Therefore, A and C are congruent. They're going to equal the same measure. Our final theorem is the congruent supplements theorem. It's just like the congruent complements, except that we're talking about supplementary angles. So A is supplementary to B. C is supplementary to B as well. Therefore, A and C are congruent. Okay. So we've had a lot of definitions, theorems, and postulates, but you're going to use these to practice identifying them and looking at the differences between them, especially the different theorems, like the complement theorem versus the definition of complementary angles. So if we look at the definition of complementary angles, it's talking about a number, the sum is 90. However, the complement theorem doesn't have anything to do with 90. It just says that if two angles form a right angle, then they're complementary. Similarly, the definition of supplementary angles say that angles add to 180, but the supplement theorem just says that if two angles form a linear pair, then they're supplementary. So they don't have any numbers with this. So look over these notes as you attempt the questions tonight.